Okay, first one, by value. So why do we start with by value? One of the reasons is because um, it is very common, it's very simple, it is very widely used. It is the only actual approach in real Java, okay? And there's this kind of slightly lengthy set of words right here. So I'm going to kind of walk through this and what it's kind of trying to say. But this kind of comes from the book. But here's the idea. So with a pass by value, the formal parameter, right now, the formal parameter is the definition that happens inside the, inside the function, inside the method. There's a formal parameter. And that's like a local variable in the activation record. And you already know that, right, of a formal parameter. It creates a local variable in the activation record. And but when it's created, it's initialized with the values that come in through the actual parameters. And again, you're like, yeah, I know isn't that what everything is? Probably what you're thinking. And the answer is kind of yes, okay? But here's an example anyway, just to kind of give you the illustration. So what I've got here is a method or a function called plus, and I've got a function called f. F is going to set up and then call plus, okay? Now this is the activation record for f over here on the right. Notice that I've got f has a variable called x, initialized to 3, boom. It's got a y, initialized to 4, boom. And it's got a z that isn't initialized to anything. It's allocated, but it's, we got to call plus to figure that out. And we're going to call plus, we're going to pass x, and we're going to pass y. We are passing that x and that y. In other words, the value 3 and 4 is getting passed. As soon as we call plus, it creates, we get this activation record, okay? Let's look in plus. Plus in its parameter list has a, which is an integer, and b, which is an integer. There's a, there's b. So it allocates those. And then, because we've called plus passing x and y, the value 3 gets put for x, which gets bound to a, and then 3 becomes the value. 4, which is y, gets passed as the second value. So when when this plus is called, b gets initialized with whatever was passed in. Again, that was 4. So now you've got 3 and 4. Previous activation register, pointing back to kind of where we came from. And anyway, that's just to kind of show you this basic notion. And again, this probably, my guess is that this is kind of already second nature, or what you would have guessed was already going on, right? And when you get an approach that's this widely used, that no shock. Now, one of the questions is, okay, pass by value, right? In pass by value, I'm not really giving you an explicit view out, if that makes sense. In other words, and we'll talk later about pass by variable. Pascal, for example, you could designate different types of variables. And if you said it was a value, then the value could come in and nothing could go out. But if you said it was a variable, then you could it would change automatically, right? Well, and then you get to languages like C, which don't do that. Again, very much pass by value. But the question is, okay, so kind of back to bullet number 1, I pass parameters by value, and the changes to a formal parameter don't affect the actual parameter. Okay, what that means is that if I pass in, let me back up over here. If I call this thing here, and there are some changes out here to these, if there's a change in here to the formal parameters, like right here when I go a plus equals b and I return a, whatever, okay, that's not doing anything to x and y out here, right? All I'm doing is just like making a copy of x, dropping it in, binding that to a, and putting it over here. And then after that, these are disconnected. There's no relationship between this 3 over here as a and that 3 over there as x, other than the fact that a was initialized by copying the value of x, and that b was initialized by copying the value of y. But if I do anything to A or B, nothing changes to X or Y outside, right? That's kind of what that's trying to say. But it is still possible for the called method, right, inside the function to do stuff based upon what it was given. So like, imagine that someone like hands me a, I don't know, I got a wedding announcement from a student, the other day, and guess what? I didn't get the original wedding announcement. I mean, I got a copy, right? I got one of probably hundreds or whatever, depending on how popular these people are. I got a copy, right? And I get this thing, right? But imagine that instead, right, I mean, anything I do here has no impact on anybody. I look at the thing, I look at their pictures, whatever. Follow me with this. The metaphor might make some sense when I'm done. But imagine instead of giving me, this, can you hear this? Yeah, that's the wedding announcement. I've got it in my hand. But imagine that instead of that, you handed me a phone number. Well, once again, I just copied your number. You had a number, I copied the number, wrote the number down. Okay, but now that I have a phone number, I can call the number and do stuff like call the number and order a pizza for you, or call the number and chew people out, or call the number and make an enemy out of somebody. So I can have effect, even though the thing you gave me was just a copy, and that's passed by value. I make a local copy of whatever you passed in the actual parameters. I make a local copy in the formal parameters. Having done that, I don't directly make any changes, but if you've given me some extra power, oh gosh, I don't know, how about a pointer, or a reference? What about that? Well, you just gave me a phone number out, and now I can do things with that, right? I don't know, better example, I'm in jail, but I have a phone number, whatever. But let's look at the example, okay? So here we have, over here, we have the activation record for, well, let's break it down over here. We've got this function f. Function f has a const cell. This is Java, and it has this const cell, and it's going to make a new one, okay? And it's going to do a const cell with 0 and null. So the head is 0, the tail is null. And I'm going to do a new on that thing. So I'm going to allocate that out there somewhere. And I'm going to take that address is going to be referenced via x. And then I'm going to pass, I'm going to call alter. Now here's the function alter. I'm going to pass 3 and x, okay? Alter wants two things. It wants new head, and it wants this const cell. And it's going to call this new head, well, it's going to call it new head. And it's going to call this one C, okay? This ought to be reasonably comfortable to you. Then what happens when f is running over here? It's got a local variable called x, okay, when f is running. And when we make this new on const cell, boom, the little node shows up over here with head 0 and tail null, because that's what we said to do. And that's it. That's the activation record for the function f. Then we make our call to alter. So at the beginning right here, when alter starts, we make that call to alter. And alter has two variables in its parameter list. New head, there's new head, and const cell, C, which is a const cell. There's C. We passed in 3, okay, so there's 3. Now that 3 didn't come from it. We just said 3. So when it made new head right here, took that value, copied it, and bound that value in the activation record. C, however, was given. We had, remember, we made the const cell. There's x. We hand that value in. Now C here is the same value as x, but in effect they're both pointers. So x points to that node. C points to the very same node because the value here and the value here are identical. Put it another way, they're the same phone number, okay? I got the same phone number here, same phone number there. They both point to the same place. All right. That's what happens when this whole thing starts, okay? And then what you're going to see is inside this function alter, we're going to call set head. We're going to go c dot set head with new head. So we're going to take this new head right here, and we are going to do a set head on C using that. Let's go to the next one. Actually, well, then we get to the end. I mean, and that really, in a sense, it sort of doesn't matter. What matters is this next step that we get to, which is when we're all done, we set C equal to null. So what we did, let me back up again. That's where we started. I get to this set head, new head. So new head is 3. And so I take C points to this. C dot set head, which affects that value, okay, in that object. And I set that to be 3, okay? You following it? The 3 came in, new head had the value 3, then I'm using that same value here to say set head equal to 3. And then I set C equal to null, and watch it. C's pointing, I set C equal to null, C stops pointing. But so inside this function, I didn't directly affect anything outside from the perspective of the parameter list, or who was calling. But because you passed me in a pointer or a reference or phone number, I was able to call out and do damage or do changes or make, do some positive things, even though I didn't have a direct connection. I hope that makes sense. That's it for pass by value.